Okay, good evening. Good evening to all. This is Sathyamoorthy, verified plus educator in the Unacademy platform. This is a fourth session, part 4, higher order differential equations with constant coefficients, part 4. Already we have completed 3 cases in the up to the part 3. It's a part 4 in the differential equation. Coming into the part 4. Yes, it's for the differential equation in the subject of engineering mathematics for the GATE aspirants who are appearing for the GATE 2020 mechanical engineering as well as other stream exams. It's common for the mechanical, civil, for all the branches. The differential equations are common. So stay tuned on the YouTube live channel here. So higher order linear differential equations with constant coefficients that are these are the things. It's a general form of the differential equation. Then we are replacing the d divided by dx by d and d square here. dy divided by dx is given it as capital D into y. Here d stands for the differential operator. Then d square y divided by dx square is equal to capital D square into y. Then d cube y divided by dx cube is equal to capital D cube into y. The general formula for the differential equation is given it as d power n y divided by dx power n. So here d divided by dx is replaced by the term capital D power n. Here capital D stands for the differential operator. As per the differential operator, coming to the differential operator, it's a second order linear differential equation. This differential equation is converted into this form by substituting the d divided by dx by capital D. Okay, these are the things. Okay, please visit the previous YouTube classes, the part 1, part 2 and part 3, the higher order differential equations. You can get a more clarification about the differential equation. Here capital D stands for the operation of the differential form, then 1 divided by D stands for the operation of integration. Then complete solution of the differential equation. So solution of the differential equation is y. The complete solution is the complementary function plus particular integral. Here complementary function is the solution to the LHS of the given differential equation. Particular integral, it is the solution to the RHS of the given differential equation. The next one, here these are the complementary functions. Okay, we had a very good discussions about the complementary function and particular integral in the previous classes itself. Okay, visit the previous classes that was handled by me. Differential equation, higher order differential equation, part 1 and part 2, part 3. Okay, in those 3 classes, I have explained the complementary function and particular integral. These are the complementary functions table. Then particular integral. These are the particular integral. Already we have completed the e power ax and sin ax or cos ax. Here in this class we are going to discuss about the case 4, r which is equal to x power n. Before entering into the r which is equal to x power n, we are going to have the one more problem in the r which is equal to sin ax or cos ax format. We know that in the sin ax, what we are doing here, we have to replace the d square in the denominator by minus of a square for the category of case 3, that is sin ax or cos ax format. Here a is the coefficient of x in the trigonometric equation. Before entering into the case 2, we are going to have one more problem in the category of sin ax. Then we are moving to the next category, x power n. The particular integral of d square plus a square the whole square into y is equal to sin ax is equal to the sin ax. Okay, these are the 4 options. We have to identify the correct options among the 4 options. Coming to the solution, particular integral. We know that the particular integral is the solution to the RHS of the given differential equation. The solution for the equation is given it as, yes, we know that particular integral pi is equal to 1 divided by f of d into sin ax into sin ax. What we are doing here, we have to replace the d square in the denominator by a, the coefficient here. The function is given it as 1 divided by d square plus a square the whole square, okay, into sin ax into here sin ax. We are replacing the d square by minus of a square. When we are replacing the d square by minus of a square, what we are getting here? 1 divided by minus of a square is equal to minus a square plus a square into, okay, the whole square into sin ax. So this is a format here, differential equation. Minus a square plus a square is equal to, the denominator is equal 0. 1 divided by 0 is equal to infinity. So the ordinary rules fails here. For the differential equation, there will be a solution, but coming to this category, there is a no solution, it's infinity. So we have to change the format. Coming to the denominator is equal to 0 format. When f of a is equal to 0 in the denominator, when f of a is equal to 0 in the denominator, we have to multiply the x in the numerator, then we have to differentiate the denominator one time with respect to the d, then again we have to replace the d square by minus of a square in the equation. So this is a procedure. It's common for all the categories. I have mentioned it only on in the e power ax category. It is common for when the 1 divided by 0, f of a 0 in the denominator. So we have to multiply the x in the numerator, then we have to differentiate denominator one time with respect to the differential operator d. Yes, coming to the problem. Here we have to differentiate. First we have to multiply the x. We are multiplying the x and the numerator, x into 1 divided by, we have to differentiate. So d square plus a square the whole square is equal to 2 into d square plus a square into, again we have to differentiate the d square one time. So 2d into 2d. Again sin ax. Again the same procedure, we have to replace the denominator d square by minus of a square. Again x into 1 divided by 2 into d is equal to 4d into 4d into minus of a square plus a square into sin ax. Again the denominator is infinity, it's 0. So again the denominator is equal to 0. Again it is equal to 0. So again we have to multiply the x in the numerator, then again second time we have to differentiate the denominator is equal to x into x square. We are differentiating this thing, multiply this 4d inside, what we are getting here, 4d cube. For 4d cube, when you are differentiating the 4d cube, 2 into 2, 4d. When you are multiplying the 4d inside, 4d into d square is equal to 4d cube. Differentiating one time, 12d square, then inside 4d, multiply the 4d into a square is equal to, when you are differentiating 4d is equal to 4, so 4a square into sin ax into sin ax. So this is the format. Now again replace the denominator d square by minus of a square is equal to x square divided by d 12 into minus of a square into, sorry, plus 4 into a square into here sin ax into sin ax. So this is the format. As per the format, 12 minus 12 plus 4 minus 8. So minus x square divided by 8 into sin ax. So this is the solution for the equation. Minus x square divided by 8 into sin ax. So coming to the problem, minus x square divided by here 8a square. So it's 8a square. The denominator we are having a, so 8a square. This is the solution. So here option B is the solution for the given problem, because minus x square divided by 8a square into sin ax. So this is the solution. Next we are moving to the next case. The next case, we had a very good discussion. So the first three cases, the cases are, first case cos ax case, second one here the case 1 is RH is equal to 0, case 2 e power ax, case 3 sin ax. Now we are going to discuss about the case 4. These are the 8 very important cases. You have to practice these 8 cases in order to crack the problems in GATE as well as IES. Okay, case for RHS is equal to x power n format. Okay, before entering to the next one, okay, use my referral code. That is use my referral code in the Unacademy Moorthy MOORTHY 536 to get 10% discount while subscribing into the Unacademy platform. Okay. Then one more thing. Search my name Sathyamoorthy space V in the Unacademy learning app. Then follow me in the app. Then you get notified during the each classes, special classes as well as regular classes. Yes, next we are moving into the explanation for the case 4. It's a category of case 4 here. Particular integral PA is equal to 1 divided by f of d into x power n format. The case 4 coming to the x power n. Yes, here x power n, when x is equal to x power n, the particular integral is equal to 1 divided by f of d into x power n Here the procedure is we have to convert the we have to take this f of d into the numerator from the denominator. Then we have to expand the f of d power minus 1. Okay, we know that when you are taking the f of d from the denominator into the numerator, power minus 1. Then here the expand the f of d power minus 1 and then operate. What is meant by the f of d power minus 1? The denominator in the f of d, we have to convert it into the binomial format. We have to convert this into the binomial format. This is the format. The denominator function depends upon the variable d. So we should convert the equation into binomial format. Here binomial expansion format is 1 plus x or 1 minus x. First thing, the f of d, the denominator, we have to convert the denominator in terms of 1 plus x, 1 divided by 1 plus x, or 1 divided by 1 minus x. So when you are taking this x plus 1 into the numerator, what we are getting from this value is equal to 1 plus x power minus 1, x the whole minus 1. When you are taking this 1 minus x into the numerator, 1 minus x the whole power minus 1, whole power minus 1. So this is the formula. These are the binomial expansions. As per the binomial expansions, what we are getting here, 1 plus x is equal to formula 1 plus x the whole power minus 1 is equal to 1 minus x plus x square minus x cube plus x power 4, okay, vice versa, up to here. 1 minus x the whole power minus 1. The formula next one is 1 plus x plus x square plus x cube plus x power 4, okay, up to the infinity we are expanding. The shortcut method to remember the formulas, these two formulas, here we are having the opposite sign, plus minus. So we are using the plus minus. We are increasing continuously polynomial order, but only thing we may confuse while solving the problems. Here 1, the plus and minus, there are two different symbols, so plus minus plus minus plus minus. We are using the plus minus alternatively. In this equation we are using the plus symbols continuously. How we are using it plus symbols continuously? Here both the cases minus minus, so we are using plus symbol. These are the shortcut methods to remember these formulas. Binomial expansion. Based on the binomial expansion, we are expanding the f of d power minus 1. Okay, before taking the f of d from denominator into the numerator, we have to convert the f of d in the format of 1 plus x or 1 minus x format in the denominator itself. Then we have to take this denominator into the numerator. Yes, x power n category. This is x power n category. Particular integral is equal to 1 divided by f of d into x power n. Solve the equation d square y divided by dx square, d square y divided by dx square minus 5 into dy divided by dx plus 6y is equal to x square plus 3. So this is the condition. Here the solve, okay, solve means we have to identify the complete solution for the given differential equation. The complete solution, it comprises of two categories. One is a complementary function, other one is particular integral. The complementary function is solution to the LHS of the given differential equation. Then this RHS, the solution to the RHS is particular integral. First we are going to derive the complementary function for the given differential equation. What we are doing here, we have to replace the d divided by dx is equal to capital D. So d square y divided by dx square is replaced by d square into y. Then 5 into d plus 6. Okay, here we kept this y commonly, okay, here outside is equal to x square plus 3. X square plus 3. So this is the condition. Coming to the auxiliary equation. First we need to identify the, we have to convert this differential equation into the auxiliary equation. What is meant by auxiliary equation? Okay, d square minus 5d plus 6. In this equation, d stands for the differential operator, differentiation. So here we have to replace into the another notation. Here I have used the notation m. So d square is equal to m square minus 5d is equal to 5m plus 6 is equal to 0. Plus 6 is equal to 0. M minus 2 into, okay, the shortcut method used to identify the root values here. The shortcut is when you are multiplying the two root value, it should give plus 6. When you are adding the root value, it should give minus 5. This is the shortcut. When you are multiplying the two numbers, it should give 6. When you are adding, it should give minus 5. So minus 2 and minus 3 are the possible numbers. Minus 2 into minus 3 is equal to plus 6. Minus 2 plus minus 3 is equal to minus 5. So m minus 2 and m minus 3 is the roots of the given equation. So from this equation, m1 is equal to 2, m2 is equal to 3. m1 is equal to 2, m2 is equal to 3. Here the complementary function, as per the discussions in the complementary function, here root values are real values but not equal, or different value. 2 and 3 are different. When the roots are real and different, the complementary function is given it as, this is a complementary function. When the root values are real but different, m1 is not equal to m2. In this category, we are using the complementary function is equal to a into e power m1x plus b into e power m2x. Here in the last problem, m1 is equal to 2, m2 is equal to 3. So substitute those values here. Then a into e power 2x plus b into e power 3x is the complementary function of the given equation. The next one, particular integral. The particular integral is given by here 1 divided by f of d into x square plus 2. Here x power n format. X power n format. We know that we have to expand the formula f of d here. The f of d in the denominator is converted into 1 plus x format. So coming to the explanation for the given question. The denominator, so we are taking this 6 commonly from the equation. So 6, 1 plus d square minus 5d divided by whole divided by 6. So it was converted into the 1 plus x format. So coming to this equation, this whole format is equal to compared to the 1 plus x. 1 plus x. Here x is equal to, this value is equal to x. So we have converted the denominator into 1 plus x format. 1 plus x format. Okay. Then we have to take this denominator into the numerator. We are taking 1 plus x into the numerator, 1 plus x whole power minus 1. Then what is the procedure here? Alternative symbols. Okay, the binomial expansion is expanded up to the polynomial order, the highest polynomial order in the given x power n. In the given x power n. Here x power 2, n is equal to 2. So we can stop the expansion format up to the d square. More than the d square gives the 0 value. Why the more than the d square is equal to 0? We know that x square, when you are differentiating one time x square, it will give 2x. When you are differentiating 2 times d square of x square, second time differentiation it gives because the d stands for the differentiation, the multiplication d stands for differentiation, d square stands for 2 time differentiation of the given function. So here 2, the third time differentiation d cube into x square. So third time differentiation is equal to the constant 2. We are differentiating the 2 with respect to the x, it is 0, constant differentiation 0. So the d cube in the equation, binomial expansion equation, it gives 0. So we can stop the binomial expansion up to the d square. We know the formula. When you are taking 1 plus x into the numerator, 1 plus x whole power minus 1. This is the formula. So 1 plus x whole power minus 1 formula. Here 1 minus x plus x square plus x square minus x cube. So we are expanding as per this formula. When you are expanding this formula, what we are getting here? 1, this is the x. So 1 minus x plus x square. The whole term is x. So 1 minus x plus d square minus 5d divided by 6 is the x. So the whole square. We are stopping this formula itself. Coming to the expansion, minus d square divided by 6, minus into minus plus. So plus 5d divided by 6. We have to expand this formula. A minus b the whole square, d square minus 5d the whole square is equal to a minus d. First a square, d square the whole square is equal to d power 4 divided by 36. The 6 square is equal to 36 plus b square, 5d the whole square, 5 square 25, d square divided by 36 minus 2ab, 2 into d square into 5d, that is minus 10d cube divided by 36. So this is the formula. Here what we are doing here in this formula, we have to eliminate the higher order terms. The value d power d, the power of the d is more than 2 is eliminated here. So we can keep this d square d power 4 eliminated. So d cube eliminated. So the remaining things used in the formula is d square 1 minus d square plus 5d divided by 6 plus 25d square divided by 36. So these are the formulas used here. Now multiply this x square plus 3 inside, x square plus 3. We are multiplying this x square plus 3, 1 into x square plus 3, x square plus 3. So this is the condition here. Is it okay? Yes. Minus d square, 2 time differentiation of the d is equal to 2. So instead of d square we are substituting 2. 2 divided by 6 minus 2 divided by 6 plus 1 time differentiation equal to 2x. So 5 into 2x is equal to 10x. 10x divided by 6 plus 2 times differentiation again it's 2. 25 into 2 is equal to 50 divided by 36. Here we are expanding the formula, x cube plus 3 minus 2 and 6 cancel. So 1 divided by 3. Then 5 divided by 6 is 10 divided by 6 is equal to 5 divided by 3. 50 divided by 36 is equal to 25 divided by 18. So these are the conditions here. Take the LCM. Okay, 18 is the LCM here. 18 multiply the 18 x square plus 18 here. We have to multiply the 6 on both, okay, denominator as well as numerator. So 5 into 6 equal to 30x plus remaining the constant values are added, it is 73. So after simplifying this equation we are getting particular integral is equal to 1 divided by 108 into 18x square plus 30x plus 73 plus 73. So here y we know that the complete solution of the given differential equation, it's a addition of complementary function plus particular integral. The complementary function is solution to the LHS. So this is the complementary function for the given equation, a into e power 2x plus b into e power 3x. This is the complementary solution. Then particular integral, this is a particular integral. Then add the complementary function and then particular integral. This is a solution to the given equation. Okay, is it okay to you guys? Yes, next we are moving into the next problem. After discussing one more problem, we are moving into the multiple choice questions. Yes, here x cube, as per the discussions in the previous problem, here x square, that's why we have stopped the differential operator up to the d square. In this problem, x cube, so we can keep the differential operator up to the d cube. The more than the d cube is eliminated here, d power 4 or 4 and at all eliminated here. 1 divided by d square into 1 plus d square minus 2d the whole power minus 1 into x cube. Okay, how we have derived this formula? Coming to the first step, particular integral is equal to 1 divided by f of d. Here f of d is d power 4 minus 2d cube plus d square is the function, depends upon the variable d, into x cube. Here we have to convert this denominator into 1 plus x format. As per the previous problem discussion, we have to convert into the binomial expansion format. Here I am taking d square, okay, commonly from the equation. So now taking d square 1 plus d square, when you are taking d square, remaining d square minus, you are taking d square from the d cube, so minus 2d. So this is a function. Here what we are doing here, we have to take this denominator into the numerator. This value is equal to 1 plus x. The whole term is equal to the 1 plus x whole power minus 1. This is in this format. 1 plus x whole power minus 1 format. Yes. Coming into this equation, here we have to expand 1 plus x whole power minus 1. We know the formula for the 1 plus x whole power minus 1 is the binomial expansion. It 1 minus x plus x square minus x cube plus x power 4. Okay, then we are expanding. Then as per this formula, here, so expand 1 minus x plus x square minus x cube, and expand this formula, then 1 minus d square minus into minus plus, so plus 2d. Here a minus b the whole square, a square is equal to d power 4, b square is equal to 2d the whole square, 4d square, minus 2ab is equal to 2 into d square into 2d is equal to minus 4d cube, minus a minus b the whole cube. The a minus b the whole cube, we know the formula for the a minus b the whole cube. A minus b the whole cube is equal to a cube plus b cube plus 3 a square b plus 2. Here 2 a square b into 2 ab square. So this is the formula for the equation. Now as per the equation, we are expanding it. Now coming to the equation, a minus b the whole cube, here a is equal to d square, so a cube is equal to d power 6 plus b cube 2d the whole cube is equal to 8d cube minus 2 into 2 a square b, a square is equal to d power 4, so 2 into d power 4 into 2d is equal to minus 4 d power 5 minus, here again 2ab square, 2 into d square into 4 into d square is equal to minus 8 d power 4. Here the x cube, as per the discussions in the previous problem, here x square, so we have stopped the differential operator up to the d square. The more than the d square is equal to 0. So here in this problem we are having x cube, so we have to stop the differential operator up to the d power 3. The more than the d power 3 are 0. So the remaining things are eliminated. Higher order, d power 4 eliminated, d power 6 eliminated, d power 5 eliminated, d power 4 eliminated. The remaining things are 1 minus d square plus 2d plus 4d square minus 4d cube, then plus 8 d cube. The differentiation, we know that the differentiation x cube, one time differentiation of x cube is equal to 3x square. Two time differentiation of x square is equal to 6x. Then third time differential expansion is equal to 6. The more than the 3 is equal to 0. When you are differentiating the constant value, it should give 0. Yes. So coming to the equation here, we have to multiply the values inside. So multiply the x cube here. 1 into x cube is equal to x cube. First, before we have to convert this d square, all the d value, 2d, d square minus d square plus 4d square, it's plus 3d square, then d cube minus 4d cube plus 8d cube is equal to plus 4d cube. So multiply the x cube inside. 1 into x cube, 2 into d, one time differentiation equal to 3x square. So 2 into 3x square is equal to 6x square. Then 2 time differentiation equal to 6x. So 3 into 6 is equal to 18x plus the 3 time differentiation equal to 6. 4 into 6 is equal to 24. 4 into 6 is equal to 24. Now the 2 times 1 divided by d stands for the differentiation. Here 1 divided by d square, 1 divided by d stands for the integration. Here 1 divided by d square stands for 2 times integration of the function. Here d square stands for 2 times differentiation of the given function. The 1 divided by d square stands for 2 times integration of the given function, because coming to the equation, yes, 1 divided by d stands for operation of integration. So as per this concept, so we have to integrate 2 time, 1 time integration. X cube is equal to x power 4 divided by 4. Then 6 into x square is equal to x cube divided by 3. When we are integrating the x, it is 18 into x square divided by 2. Then plus 24x. Again the second time integration. X power 4 integrating x power 5 divided by 5. So 4 into 5, 20. Then x cube integration, x power 4 divided by 4. So x power 4 divided by 4, 3 into 4 is equal to 12. Then x square integration equal to x cube divided by 3. So x cube divided by 3. 2 into 3, 6. Then it is x square divided by 2. X integration, x square divided by 2. Okay, simplify this equation. X power 5 divided by 20 plus cancel this 6 and 12. So 1 divided by 2. X power 4 divided by 2 plus 3x cube. 3x cube. It is cancel the 3 and 18. So 6 and 18. It's a 3x cube. Cancel this 24 divided by 2. It's 12x square. This is the particular integral of the given equation. So we know that the solution. So here the only thing, particular integral. We have identified the particular integral for the given question. The given differential equation. This is the given differential equation. Okay, I hope I think I gave a clear explanation regarding the x power n formula. Next we are going to have the multiple choice question. Okay, I am showing the multiple choice question. Okay, try yourself and try to give the answer in the live chat. Okay, after showing the question, I will solve the question. Okay, then before that, okay, try yourself. Coming to the equation, particular integral of d square minus 1 into y is equal to x. What is the answer for the particular integral of the function? Coming to the particular integral, we know that the particular integral is equal to PI is equal to 1 divided by f of d into x power n. X power n. Then we have to take this f of d into the numerator, that is f of d the whole power minus 1 into x power n into x power n. This is the condition here. Yes. So as per this discussion here, 1 divided by f of d is equal to d square minus 1 into x. X power n is equal to here x. So the thing is, we have to convert the denominator into 1 plus x or 1 minus x format. So take the minus outside. So it was converted into the 1 minus d square format, 1 minus d square, that is 1 minus x format into x. Take this denominator to the numerator, minus into 1 minus d square the power whole power minus 1 into x. We know that 1 minus x, it's 1 minus x format whole power minus 1. So 1 minus d square is equal to 1 minus x. Here x is equal to d square whole power minus 1. We know the polynomial expansion formula. This is a polynomial expansion. When you are getting the 1 minus x whole power minus 1, the formula is 1 plus x square plus x cube plus x power 4. So this is the binomial expansion for the given formula. As per this formula, now expand this formula is equal to 1 plus d square the whole square plus d power 4. Okay, we are expanding here, minus front side minus of this value into x. Here x, as per the discussions in the previous problem, when x power 3 we have to stop up to the 3 d power 3. When it is x, we have to stop d itself. The power more than the 1, the d power 1 is eliminated here. So here what we are doing here, we are eliminating d square d power 4. Only thing, minus, multiply this x inside, it is minus x. So the answer is here minus x. So here minus x is the answer for the given question. So option A is the correct answer for the given question. So minus x. Okay. Next we are moving to the next question. The second question to you. Yes, the particular integral of, again, the particular integral of d square y divided by dx square minus dy divided by dx is equal to x. So this is the format here. Yes, coming to this, before solving this equation, okay, myself Sathyamoorthy, verified GATE plus educator in the Unacademy platform. Okay, search my name Sathyamoorthy space V in the Unacademy learning app. Then follow me. Then you get notified during each classes, special classes as well as plus courses. Here in the bottom point, this is my referral code. Moorthy 536. Use this referral code while subscribing in the Unacademy platform. You can get 10% discount here by using this code. Okay, Unacademy platform is the very good educational platform to understand the concept very well. We are the India's topmost educator are teaching the better subjects, mechanical engineering as well as other subjects for the GATE. Then it is also available for the TNPSC, UPSC, bank exam, for everything. For the subscription, to subscribe in the Unacademy, use this code Moorthy536. So you can get 10% discount while subscribing into the Unacademy platform. Okay, through this code, referral code. Apply this code, then you can get the 10% discount. Yes, coming to this equation here, particular integral of d square y divided by dx square minus dy divided by dx is equal to x. What is the answer for the given question? Okay, bring your paper and pen. Before I am solving, try this problem as per our discussions in the previous slides. Okay, try to find out the solution and comment your answers in the live chat. Okay, now I am giving the explanation for this question. We are going to solve this question. We are going to identify the correct option for the given differential equation. We know that first we have to convert d square y divided by dx square is replaced by capital D square into y minus dy into dy is a function into dy is equal to x. Then here d square minus d into y is equal to x. The particular integral is given it as particular integral. We know that PA is equal to 1 divided by f of d. 1 divided by f of d is equal to d square minus d into x. Here the denominator we have to convert it into the binomial expansion formula. It's 1 plus x or 1 minus x formula. I am taking this minus d outside. So it is equal to minus 1 divided by d into 1 divided by 1 minus d square. 1 minus d square. And other method, okay, wait a minute. Yes, we can write the same thing as minus 1 divided by d into 1 minus d square. So here 1 minus d square is equal to 1 minus x format. Here x is equal to d square into x. So what we are doing here, we have to replace this thing. Is equal to minus 1 divided by d into 1 minus d square the whole power minus 1 into x. We know that when the x power is 1, we have to stop this expansion up to the d power 1. So coming to the binomial expansion, minus 1 divided by d into 1 plus d square plus d power 4, okay, etc. So we have to stop this thing here. The higher order more than 1 are eliminated. So multiply the x inside. When you are multiplying the x inside, yes. Wait a minute. Minus d. We took this d outside. Okay. And now expand. Multiply the x inside. We are multiplying the x. We are getting only x minus x divided by d. So we have to expand this formula here. Yes, this is the equation. D square y minus d is equal to x. Here d square minus d, we have to take this d outside. We are taking the minus d outside. What we are getting here? 1 minus d. Okay, it's d. Wait a minute, it's a d. There is a small mistake here. Wait a minute. Yes, when you are taking t, 1 minus d. It's 1 minus d. So here, yes. So 1 plus d square plus d cube, etc. into x. Then multiply the x inside. Multiply the x inside. Is equal to minus 1 divided by d into x plus 1. X plus 1. Then differentiate, integrate one time. 1 divided by d stands for the integration. Okay, already we had a discussions about the previous things. The differential operator as plus integral operator. Here 1 divided by d stands for the integration. So we have to integrate the given function one time. Then we are integrating. What we are getting here is equal to x integration is equal to x square divided by 2, x square divided by 2, then plus x, multiply this minus 1 inside. From this equation what we are getting here equal to answer. This is the answer, minus x square divided by 2 minus x. So this is the answer for the given question. Here the option C is the correct answer. We are having the option C as same like our answer. So this is the answer, option C. It's minus x square divided by 2 minus x. So this is the answer for the given question. Okay, if you are having any doubt, okay, let us please comment your doubts in the live chat so I can help you here, or don't hesitate to ask your doubts here. Okay, if you are having any doubt, okay, please visit the Unacademy platform also. We can discuss in the live chat manner. Okay, I am taking the special classes as well as plus courses for the engineering mathematics in the Unacademy platform. Yes, we are moving into the next question. It's the next question to you. Okay, the particular integral of the, again coming to the differential equation, the particular integral of d cube minus 3d square minus 60 plus 8 into y is equal to x is what about the particular integral for the given question. Okay, bring your paper and pen. Okay, try to give your answers in the live chat. Work it out and give your answer. Now I am deriving this differential equation here. You know that particular integral pi is equal to 1 divided by f of d. 1 divided by f of d is equal to d cube minus 3d square minus 6d plus 8 plus 8 into x. What we are doing here, we have to convert this equation into the 1 plus x format, the binomial expansion format. So I am taking this 8 commonly from the equation. From this equation take the 8. So here 1 divided by 8, when you are taking the 8, 1 plus the remaining things are taken it as x, d cube minus 3d square minus 60 divided by 8. 60 divided by 8. Okay. Into x. So we have to take this denominator into the numerator. When we are taking this denominator into the numerator, what we are getting here is equal to 1 divided by 8 into 1 plus d cube minus 3d square minus 6d divided by 8, the whole power minus 1 into x. Here the polynomial here differential order is more than cube is eliminated. 1 plus x format whole power minus 1. It's a category of 1 plus x format. It is 1 plus x format, this equation. So x is equal to d cube minus 3d square minus 60 divided by 8. So coming to the binomial expansion, this is the binomial expansion for the equation. 1 plus x whole power minus 1. Yeah, 1 minus x plus x square minus x cube is the formula for the 1 plus x the whole power minus 1. Coming to the equation here. Yes, here what we are doing, we have to eliminate the higher order terms. 1 minus x is more than sufficient here because the order 2, the square is eliminated. So we are eliminating d cube minus 3d square. The remaining thing is 1 divided by 8 into 1 minus of minus plus 6, because we have to eliminate the term 1 minus d cube minus 3d square minus 6d divided by 8. plus the remaining term. The remaining term eliminated. So we are eliminating here these things. So what we are getting here, 1 minus 8. So 1 divided by 8 minus of minus plus 8. Okay, so 6d divided by 8. 6d divided by 8 into x. Now multiply the x inside. When you are multiplying the x inside, we are getting answer is equal to 1 divided by 8 into x plus. When you are differentiating one time d, you are getting 1. So 6 divided by 8. 6 divided by 8. From this equation, here, from this equation, solution is equal to 1 divided by 8 into x plus 6 and 8. Cancel the, simplify the 6 divided by 8 is equal to 3 divided by 4. So this is the answer. So 1 divided by 8 into x plus 3 divided by 4 is the answer. So here option A is the answer for the given question. Yes, it is the answer to the given question. Next we are moving into the next question. Okay, listen it. Next we are moving into the next question. Yes, next question to you. What about the answer for this question? Here, particular integral of d square uh, into d square plus 4 into y is equal to 96x square. Okay, Linus, work it out and ping your answers in the live chat. Okay, give your answer. Then I am moving into the explanation for the question. Okay, in your window, okay, your YouTube window below, we are having the option live chat. Okay, click that live chat. Then you can ask you can comment your doubts in the live chat. Okay, ping your comments as well as doubts in the live chat box. Okay, also like this video, share with your friends, those who are preparing for the GATE examination. Okay, share this video to your friend. Okay, so coming to the explanation, particular integral pi, here pi is equal to pi is equal to 1 divided by d square into d square plus 4 into plus 4 into 96x square. The thing is, we have to convert the denominator f of d in terms of 1 plus x. So we are converting into the 1 plus x, 1 divided by, take the 4 outside, 4d square. So 1 plus d square divided by 4 into 96x square. 96x square. So 4 and 96, cancel the 4 and 96, we are getting 24. 24 divided by d square. Take this denominator into the numerator. So 1 plus d square divided by 4 whole power minus 1 into x square. So this is the equation. Here we have to convert this formula. 1 plus x the whole power minus 1 is, we know that 1 minus x plus x square minus x cube plus x power 4. Okay, then we are expanding, okay, continuously as per this discussion. 24 divided by we have to stop this uh, differential power up to the square, because here x power 2, so we have to stop up to the d power 2. The more than d power 2, d cube, d4, d5 are eliminated. So 24 divided by d square into 1 minus d square divided by 4, okay, plus d square power square is equal to d power 4 divided by 16, okay, into x square. We are eliminating the higher order, only we are getting this lower order. So 24 divided by d square, multiply the x inside. So x square 2 times differentiation is equal to 2 divided by 4. So that's 2 times differentiation. Then cancel this 2 time differentiation. What we are getting here, the 2 times differentiation is a 2 divided by 4, that is equal to 1 divided by 4. The 2 time integration, 1 divided by d square stands for 2 time integration. So 1 time integration is equal to 24 divided by d is equal to, it's x cube divided by 3 plus it is equal to 1 divided by 2, x square. Yeah, option D is the correct answer as per our discussion. We are having the option 2x power 4 minus 6x square. So the option D is the correct answer for the given differential equation. So D is the correct answer for the given differential equation. Next we are moving to the next case. Next question, we are going to have the final question in this session, again from the RHS equal to X category. Again it is R which is equal to X category. Coming to this problem, particular integral Pi is equal to, we know that 1 divided by d cube plus 8 into x power 4 plus 2x plus 1. The x power 4, so we can take this d power up to the 4, more than the d power eliminated. So 1 divided by 8, take this 8 commonly. So 1 plus d cube divided by 8 into x power 4 plus 2x plus 1. So expand this formula, 1 divided by 8 into 1 plus d cube divided by 8 whole power minus 1 into x power 4 plus 2x plus 1. So this is the condition. From this equation, we know that 1 divided by x, expand this formula as per the 1 minus x plus x square formula. So 1 divided by, we know that 1 plus x whole power minus 1 expansion, binomial expansion, 1 minus d, so d cube divided by 8. Then plus d square, that is d square equal to d power 6 divided by 64 into x power 4 plus 2x plus 1. So eliminate the higher order, this order. Now multiply inside, 1 divided by 8 into inside x power 4 plus 2x plus 1 into the RHS multiplication. Now the 3 times the differentiation, 3 times differentiation, 1 time differentiation is equal to, 1 time differentiation of the equation is equal to, here 1 time differentiation is equal to, when you are 1 time differentiating, it is equal to 1 time, it is 4 into x cube. Second time it's 12 into x square. Its third time 24 into x. Now multiply, minus 24 into x. Now 3 time differentiation of the 2x is equal to 0. So this is the equation. Now 1 divided by 8 here, divided by 8, cancel the 8 and 24, we are getting 3 because d cube divided by 8, so 3, here x power 4, here 3x 2x, minus 3x plus 2x is equal to minus x plus 1. So this is the equation here. So 1 divided by 8 x power 4 minus it's a equation. So equation is equal to 1 divided by 8 into x power 4 minus x plus 1. It's a option B. Coming to the given options, option B is the correct answer for the given differential equation. Okay. These are the discussions about the x power n category. There are 8 cases in the differential equation. We are discussing one by one the continual YouTube live classes. Yes. Here. This is the case. Already we have discussed case 1, 2, 3 in the first 3 classes. Case 4 we have discussed today. Okay, in the forthcoming YouTube classes we are going to discuss about the remaining cases. Case 5, case 6, case 7 and case 8. Until bye from the Sathyamoorthy. Okay, thank you so much.